And welcome here to this wonderful venue. For those of you here live and those of you watching on live stream, I'd like to welcome you to the Open Innovation Summit. I'm going to go through some logistics here, and then we'll get started. We're starting off. This is a joint presentation of Open Power Foundation and IBM. The Power Systems group actually will be doing the follow-on announcement, and then it'll be followed with some words from Tom Rosemilia, who will be closing it out, and then we'll do a Q&A. So I'm going to actually start off, without any further delay, with introducing the Open Power Foundation. My name is Gordon McKean, and I'm the chairman of the Open Power Foundation. The agenda that we're going to have for this is really walking through, giving you an introduction to what Open Power Foundation is, what we're trying to achieve, and then we'll move on to who we are, the member companies that we've got, the members that we've got signed up so far, and then I'll go on to explain a little bit about why we're here, why we're doing a press event today. So, Open Power, I guess it was about a year ago that a number of companies, the founding member companies, got together, really for the first time, face-to-face, and we really came to the conclusion that to make a big impact in the scale-out server space, warehouse scale computing, that there were going to need to be some big changes at the system level. Optimizing the interfaces between the components was really how we were going to affect the performance per dollar TCO of these server platforms. And so as a group, we decided that we needed to create an environment and an ecosystem that would allow us to work at the device level and at the system level to try and optimize these systems. So a little bit about the group. It started out as 5 member companies. We actually became an entity back at the end of last year and started to put some operations in place. We started to accept membership at that point. And from the original 5 member companies at the beginning of this year, we've now grown to over 24. I think we're up to now 26 or 26 as of a few minutes ago. So we're growing extremely fast, and we're really excited about this. The companies that are involved here cover the range of technology for this server and these platform systems, right from the device level, intellectual property contributors and chip-level companies like IBM and Suzhou PowerCore. Then we have board and system-level people that are OEMs and ODMs that are also involved. We've got a lot of companies that are in the peripheral and I/O space for memory, storage systems, networking, and acceleration. And we've got system companies, software companies that you see in the outer ring of this chart. So that's a little bit about who we are and where we're at today. A lot of companies, all focused on wanting to do the same thing, which is to really have a big impact in this scale-out server space. So that's a little bit about who we are and what we're intending to do. Now, why are we having this event? Well, it's really because we are open for business. There was a launch announcement about a year ago, but really now we've got some things in place that we think we can build off of, and we're ready to run. So we've got a web presence. We've got a content management system that allows us to share data with our member companies, and announcements and news. We can make it available through this, openpowerfoundation.org, so you can find out more about us through that. And then the real reason for this is because we really feel that we're ready to start innovating. We've got a foundation in place now. The first thing that we actually needed to do was this. It's not your typical IBM server. Looks more like something you might find at Fry's, which is what you'd expect to see in scale-out computing. This is going to be a low-cost system relative to these servers that people are in line with what people are expecting to see in this space. It's something we're very proud of and that we're building off of. We've got firmware, operating system, a Linux operating system, hypervisor, and we've got developer tools in place, and we're ready to start building on this. We've also got a pipeline of innovation that we believe is really critical to making these big differences. Again, to create that big impact, performance, price, impact in this space, we think we need to innovate at all these levels. So we've got device and SoC level work going on. We're going to have a standard product roadmap that feeds into this. We're going to have SoC availability, and this was actually critical to launching this, was IBM making Power architecture available for us to innovate at this level. We're going to have memory solutions. We've got companies that are involved at the memory component level and also at the subsystem level. So we'll be looking at some high bandwidth memory modules. We'll be looking at low latency non-volatile memories. We've got a lot of focus on our interconnect and our I/O. So networking, we've got, and we'll talk in a few minutes about where the different companies are playing, but we've got networking advances that we're looking at. Accelerators are going to be key to this space as we get into hybrid computing and a mix of infrastructure for different workloads. And then we've got high bandwidth storage. So all of these elements are going to play together to make these really innovative systems. So just mapping out that technology to the different projects. This is a bit of an eye chart. I'm actually going to, I believe that what we're going to do is we're going to be putting these charts up on our openpowerfoundation.org website shortly, and so you can actually see what's actually included in the slides there very shortly. But what you see here is the different companies and where they're playing in those spaces as we've got it mapped out now. As I say, we think that we've built a pretty good foundation, and we're hoping to actually build on this by bringing in more members to help fill out this ecosystem. So with that, what I'd like to do is actually ask Brad McCready to come up here and I think probably start with answering a question for me, which is why power and why now?
Okay, there's a question we get asked quite a bit. And the question of why power, which is a very common question, is generally comes from the perspective of, and Gordon kind of alluded to it already, is Power is really well known for building computers with doors on them. They have doors, you can walk into them, they're so big. And you just don't think of them as being scale-out computers. But the reason why Power is what we are doing and what we're about here with the Open Power Foundation is we're taking that technology that has gone to build computers with doors on them. What we're doing is we're decomposing it into its elements, and we're making it available to all of those people whose logos you saw on that chart to innovate. We're taking the processor and we're allowing people to license that processor technology, the very technology that's in that world-famous computer that's run banks, and let them innovate that and make scale-out computers. We're building firmware stacks. They're going to be open source to enable people to take that, innovate, and make computers to go into the scale-out deployments. So the answer isn't why Power, why we think we're going to take our scale-up systems and move it into the scale-out world. The answer is we're taking the Power technology that built that scale-up system and moving it into this new and very fast-growing space to enable people to innovate and do all those things that Gordon talked about. And then the second thing is why now, which is what Gordon asked. That's the other question. Why are we doing this now? And really, right now in the industry, it really represents a point in time that's a really, really special point in time, because there's a lot of things coming together. I think about this answer, I think of three things that are coming together right now as to why now. The first is we've talked about it quite a bit, which is Moore's Law. Moore's Law from the transistor scaling, it's not there. We've known that. But what's also happened over the past few years is our technology brethren have bravely gone forth and innovated and done lots of things like strained silicon, silicon on insulator, copper, lots of things to stretch that scaling out. And even that's really starting to wane. It is very, very hard to just take the silicon and keep going. You need the innovation that Gordon talked about to keep the cost performance moving forward. The second thing that's coming together right now on why now is also, along with the decline of Moore's Law, is the decline of PC volumes. If you really look at the server industry, the PC was was a handcuff, and it was a great enabler of the server industry. The PC and its volumes provided so much low-cost technology that we built our servers out of. Memory is the easiest example. Every piece of memory first came out in the PC, then we moved it to the server, and it was our low-cost memory. But the other thing that's happened is the PC volumes decline. It's an enabler to why now. Now the PC isn't going to be dominating all the specifications, and we're going to be able to innovate new specifications to do server-optimized things. I/O attach is the best example, and that's one that you'll even hear more about over the course of the day. Even on Power8, we're starting to put new I/O attach specifications to enable much more high performance, lower latency, attach of processors, network interfaces, FPGAs, all those types of things. So the decline of the PC is the second on why now. Then the third is, which is kind of the corollary or brings together what Gordon talked about, is we're entering a third generation of scale-out computing or warehouse computing. You know, we find that in the industry more and more people are talking with this language. You know, the first generation was about 15 years ago when all the big, large data centers started building big scale-out data centers, and they bought, you know, black boxes, really. They bought, you know, Dell, HP, IBM, Sun. And then the second generation, they continued to take cost performance down, building their own systems, white boxes, and their own technology themselves. And they innovated at the planar level and made optimized systems for their data centers. And now we're entering the third generation. And we think the third generation is going to look a lot like OpenPower, where we're going to see the third generation of warehouse scale computing being innovated on SoCs, advanced I/O attached, and new technologies that we hope OpenPower will bring many, many of them to the industry. So that's really the key answer to the two key questions of why power and why now. So there's your answer, Gordon. So then now we got the other $50,000 question, which I get asked 50 times a day, so I'm going to toss it your way. I'll probably save everybody a chance to have to ask it. So why is Google in OpenPower, and what are you guys planning on to do with OpenPower?
Okay, fair question. Turnabout. Google has always considered itself an innovation leader in platform technology. We've built our data centers around that innovation. And so we've always pushed the envelope for innovation at the platform level. And we looked at OpenPower as that opportunity, as Brad says, to actually launch that third generation of warehouse scale computing. Really break down the barriers that exist between the components. Create something that's greater, the whole is greater than the sum of its parts, to really fix those bottlenecks that exist between the different components that make up a system. Networking, memory subsystems, I/O subsystems, storage subsystems, and acceleration. So we're looking to advance that, and we believe that we're technology leaders that can actually help steer that and that help lead that innovation. With respect to what we're actually contributing to OpenPower at this point, I think right now we're going through a pretty detailed investigation of the suitability of the power architecture for the different workloads that we see. And as part of that evaluation and working with moving our software onto a power architecture, we're actually helping to develop and harden a lot of the code base and development tools, the operating system and the compilers. So we're working pretty closely with the rest of the member companies in helping harden that software stack. So that's really why we're here and what it is we're doing.
Yeah, thanks a lot, Gordon. Maybe I'll get asked that question a few less times now.
All right.
So what we'd like to do now is we also have some the rest of our founding members of OpenPower are out with us here today, and I'd like to call them up here to join us and let them tell you a little bit about what they're doing at OpenPower. We have Chuck Bartlett from Taiwan, leading innovator in flexible system design. We have Sumit Gupta from Nvidia, leading innovator in GPU and graphic technology, and Shiner Gilad from Gilad Shiner, excuse me, got that one backwards, but from MNOUX Technologies, interconnect and networking. So why don't you guys grab a seat here, and we'll get started. And I just not a lot of tricky questions here. Why don't each of you take a few minutes and just share with our guests here what you're doing in OpenPower, what kind of innovation you're doing, and what kind of impact you think that'll have on the industry.
I think at Taiwan, our first goal and our first focus was to build the reference developers board. It's an ATX form factor, and it's going to be, for the software developers to help get the software started, and also be a reference board for the OPF members to help them innovate and add to the design and make it even better. Going forward, Tyan will also be building other white boxes targeted to be deployed at IBM and other cloud data centers. This board and these systems are very important, as they will be the first open power systems commercially available, and it will be in addition to all the architecture will be in addition to all the data centers that have an extra choice to look at. So Tyan and with IBM will also be donating all the reference design material, and it will be on the OPF website. So that will help all the members. They can develop their software, they can use all the design files and develop their own boards and their own systems. So
great. Hey, thanks a lot, Chuck. All right, Sumit, how about Nvidia? What are you guys looking at?
Sure. So Nvidia builds GPU accelerators. Essentially, a GPU works with a CPU to accelerate an application. So we're really excited to be part of Open Power, and we're really contributing in three key technologies, we're working in three different areas. One is to bring full software support for the GPU with Power Systems. So I'm happy to announce today that we will be making it generally available in Q4 this year. So in Q4 this year, we'll have full CUDA support for Power, and we'll ship Power-based systems with IBM in Q4 this year with NVIDIA GPUs. So this will be the first time that you'll be able to buy Power and NVIDIA GPUs together and be able to use them for accelerating your applications. This is a big achievement, something we've been working together for a while. The second thing is we announced a technology called NVLink a few weeks ago at our developer conference, the GPU Technology Conference. NVLink is a high-speed processor interconnect. And what it allows us to do is, and IBM announced with us that they co-developed this. And in fact, we'll be implementing it in a future GPU called Pascal. And IBM will be implementing NVLink in a Power CPU in the future. And what this high-speed interconnect allows us to do is to build a system that is better together. You have a CPU and GPU working together at very high speeds, able to exchange data. And the Power CPUs have an amazing memory system. The GPUs, one of the reasons we are so good at what we do is the memory speeds that we can achieve. By having NVLink, we can now put both of them together. Really, the second announcement I would like to make here is that NVIDIA is going to offer NVLink as a licensed technology to members of the Open Power Foundation. And the third thing that we're working on is obviously accelerating applications with Power and GPUs together. And this is whether it's applications that the ecosystem and other members are working on, or it's applications that IBM has in their portfolio of enterprise applications. So a lot of focus on the big data and enterprise data analytics. We also made some recent announcements around machine learning. We have a terrific demo of a Java framework doing acceleration of Hadoop analytics. So a lot of activity around applications. At the end of the day, the system is only as good as the software that takes advantage of it. So a lot of the future and the long-term focus is going to be around software.
And we'll be demoing some of that at Impact with our Java acceleration.
Absolutely. Please come to Vegas. It's a nice city. And, and there's a terrific conference put up there by IBM called Impact. And we have a booth there. The Open Power Foundation has a booth. We'll be demoing a lot of our technologies there.
Yeah, we'll have some job acceleration, which we did show at GTC as well. Gilad, what about MNOUX? What are you guys looking at?
My turn.
Yeah, your turn.
So MNOUX provides end-to-end interconnect solutions based on InfiniBand and Ethernet standards. It's running at 40 and 56 gigabit per second speeds, extremely low latency, and enable people to build very efficient data centers and to increase their data center return on investment, and allowing high performance Web 2 cloud data big data applications to run faster and in a more efficient way. Beyond of bringing the high-speed connectivity into Open Power, we also bring multiple technologies into the group. One example is RDMA, or Remote Direct Memory Access. This is a technology that allows very, very fast communications within a data center with very, very low CPU utilization. And as an example, next week at IBM Impact in Las Vegas, we're going to do demonstrations for a solution that was developed together with IBM Research and many other folks that utilizing standard API, standard software interface, and RDMA, and together it increased the throughput by 10x. It's not 2, 3, 4, it's by 10x. And reducing latency by 10x for NoSQL database application. And if you're going to be there in Las Vegas, this is a great demonstration to go and see a solution that was built together within the Open Power Foundation. Another example is CloudX. And CloudX is a platform based on open cloud architecture that enables people to take off-the-shelf components of servers and storage and software and taking those elements and build the most efficient cloud for both private or public usage. And that's another technology that we're bringing to Open Power. And it's not just stopping here. MNOUX is continuing to work with IBM to explore or take advantage of capabilities within Power to continue and increase application performance and overall data center return on investment.
Great. Thanks, guys. So that's a little taste of what our founding members are doing to kick us off, get started. We have, as they mentioned, we have the demos coming up at Impact. We have a couple more FPGA examples where we've taken and attached FPGAs with our partners to the processor and sped up some Monte Carlo by about 250x through what we call our CAPI attached FPGA. We did that with Xilinx. Altera, we did a Monte Carlo with those guys that did a 250x speed up. I should get my facts straight. Xilinx, we sped up a NoSQL data server. With Altera, we sped up the Monte Carlo. But those are a couple more examples, as well as some very fast attach of non-volatile memory through some advanced I/O with Open Power. So there's a very broad breadth of innovation taking place already that we are talking about. We'll be demoing at Impact, and there's much more to come. As a matter of fact, we have quite a few Open Power members here in the audience here today. If you're an Open Power member representing an Open Power entity, just give you a hand in the air or something, you know. Yeah, great. So we got a good group of people there. Anybody see some of these guys, you know, reach out to them, say hi, you can talk to them. They're all working and helping us move Power forward. After this, you know, as we start to wrap up, just to give you a little feel for what's going on. In 2 days from now, myself and some of our Open Power members are going to hop on a plane. We're going to fly straight to China. We're going to do this event over again in China, where we have a lot of innovation taking place, some very important stuff in China. One of our founding platinum members is Suzhou Power Core, which is the first entity to license the IP from IBM and the architecture and is developing SoC microprocessors. We'll be having them talk a little bit about what they're doing in China next week, as well as a large number of system houses. We'll be building systems with Open Power in China. With quite a few of their names, you saw them on the list as well. And we got some software innovation taking place there. So we'll be talking about that next week. I mean, not next week, in a couple of days in China. I wish it was next week. But anyhow, so keep an eye out for that, and a lot of excitement going on over there. So with that, I'm going to ask my members to go ahead, and we'll wrap up this segment, and I'll introduce Doug Balog from IBM, one of my colleagues there, the GM of Power Systems. He's going to come up here, and he's going to introduce to you some of the exciting announcements we have around Power and Power8. Thanks a lot, everybody.
Thanks, Brad. So good morning to the team here in the room in San Francisco, and good day to those watching us live from around the world. First off, let me start from an IBM leadership perspective and congratulating the Open Power Foundation on your launch today. It's certainly been, as Gordon described, an exciting journey over the last year. As I think about it, and as Gordon and Brad talked, the thing we shared together, IBM and the Open Power Foundation, is that commitment to openness, that view that now is the point in time in the marketplace to make a fundamental shift around driving a new level of innovation. Of course, as you also heard, at the heart of Open Power and at the core of our new power systems is Power8 technology. But this journey didn't just start today. It's fair to say, actually, it started in some cases around our Power8 technology almost 3 years ago. As we knew at this point in time, the industry would be very hungry for a processor designed for big data. So that's where the Power8 processor began, focused on designing a solution for the big data problem. Even more recently, in the middle of last year, we announced our commitment to Linux and KVM and started opening Linux porting centers on Power around the world. Starting in Beijing, well, Brad and the team will be again here soon in a few days, but then transcending the rest of the continents. In the US, in Austin and New York, in Montpellier, France, and in Tokyo, Japan. Now 5 porting centers around the world focused on helping application developers move their applications developed natively on the Power platform. Once again, it didn't stop there. We announced, of course, Watson and the Watson group at IBM focused on that new era of cognitive computing. As many of you know, Watson runs on Linux on Power, both on our on-premise engagements and soon, actually this quarter, on Watson on Power and software in the cloud. In fact, it wasn't just about Watson on Power on software in the cloud. It was about other roles we saw Power playing in the IBM software cloud. Next, in terms of Bluemix, that composable business set of objects that allow application developers rapidly to create that next generation set of applications. And then finally, later this year, around native bare metal Power in the software cloud. We announced our $1 billion commitment, our second $1 billion commitment in the last 15 years to Linux, in this case specifically to Linux on Power. And even just recently this month, we saw one of our Open Power members, Canonical, announce their next release, 1404, I believe, to support Linux on Power. So again, what you see is this journey didn't just start today. It didn't even just start a year ago. It actually has been occurring and leading up to today's moment here over the last 3 years. So I'm excited here today, as you can tell, to talk about the next generation of IBM Power Systems, focused on open innovation, focused on being a platform designed to solve the big data problems, and clearly focused on superior economics in the cloud. It's all based on Power8 technology, but I think as you'll see in a few minutes, it's a lot more than just the processor. Let me step through each one of these 3 elements here in a few slides. First, around openness. If I think about openness, I think about 3 attributes. First off, it clearly starts with an open stack of software. And we are 100% committed to an open stack of software on the Power platform. Not only Linux and our breadth of suppliers, as I mentioned, from Canonical and Ubuntu, but also Red Hat and SUSE, but also at the virtualization level with our commitment to deliver Power KVM this quarter with Power8 Systems. And then a support for OpenStack. We all know the move in the marketplace in terms of an open stack of management, not just across a single system, but in a software-defined environment across multiple systems. I think a great demonstration of the role of scale out. So it's an open stack of software, making applications easy to port. What I'm excited to share from a business value is with the open stack of software, we now see languages like Java and interpreted languages like scripting. Those applications can now be picked up and moved without change, without any change, from Intel to Power. If our C++ application, it's a recompilation, a test, and a go. It's no more complicated than that. So we have now made application porting and application development on the Power platform simple, simple, simple. You heard from Gordon, Brad, and the Open Power Foundation members. It is about open innovation. And I think they did a better job than I could certainly do describing the roadmap and the role that Open Power Foundation will play in driving innovation for the industry. It's also about accelerators. The way I like to think about it, with the Power8 processor, we've created a super lane highway. Now we need cars driving on it. Very fast, very efficient vehicles. And so it is about that open interface that allows for that accelerator to attach to the Power system. So those are my 3 points around openness on the new Power8 systems. An open stack of software, open innovation with Open Power, and an open multi-lane highway for accelerators to participate in the server design. Moving on to data for a second. The question I get asked all the time is, so why is Power8 Systems, Power8 processor designed for big data? And I think about it the following way. If you're solving the big data problem, you need a couple things. First off, you need a processor that has lots of cores, lots of threads, and runs super fast. You got to be able to do the analytics, and those analytic equations require that kind of compute capacity to go and get the answer as fast as possible. Who wants to wait these days? Secondly, data is large. It's big, right? You need a large working space to get the maximum answer. It's really hard to get an analytics answer if you're looking at just a tiny sliver of data. You want the maximum data in your working set that you're staring at. And so our Power8 systems are designed with a very large memory working space, a terabyte per system, a terabyte per system. Finally, data's in motion. It's not at rest, it's not dormant, it's not sitting still, it's live and it's active. And so you have to have broad bandwidth across the system, not only at the memory bandwidth level, but at the I/O bandwidth level. And so all of that transpires then into, what does it mean? Got great memory, great processor, great I/O, but it translates into the ability to do analytics anywhere from 5x to 50x faster. 50x leveraging software technologies we've optimized for the Power platform. I think any business would say, boy, if you can make my business decisions more accurate, more secure, and run 50x faster, I might be interested. Secondly, if you think about the Power platform, where we've always been a great platform for database structured data. We haven't changed that. We're still doing great at database and structured data. But we also know there's new types of data being generated in the world every second of every moment. The Power8 systems are designed for all types of data now. Not only relational database, but think of the Hadoop database structures. NoSQL, key value stores, Memcache, the list goes on and on. These are the kind of data structures that our clients, many of those in the audience and watching us around the world, are dealing with every day. The Power8 systems are absolutely designed to give analytic solutions and deal with the data management across all these types of data. And finally, I described a moment ago that superlane highway we've created for the Power platform. We call it CAPI. Coherent Accelerator to Processor Interface. A little gorpy, I know. A little gorpy, but we love technology. So CAPI, what does it mean, though? You saw some great examples when you heard from the Open Power Foundation in terms of the work we're doing with Nvidia to bring accelerators right into the same address space as the processors. Or the work we're doing with MNOUX around RDMA, remote data memory access, to bring the ability for scale-out computing and access technology across platforms for up to 10x memory bandwidth improvement. The work we're doing with other accelerator companies, right, to bring new purpose-built accelerators to the platform. So I talked about the highway. We're filling that highway with Porsches around the world. Lots of speed, lots of capability, lots of business value in solving the big data problem, reaching beyond that 50x and beyond. So that's big data. Let's talk about scale-out economics for the cloud in a secure manner. As I talk with my clients around the world, whether they be in government, whether they be in finance, whether they be in healthcare, whether they be in utilities, they're all looking for ways to move and embrace the cloud for new economic models. At the same time, though they have a core infrastructure that runs their business on-premise, they're proud of that infrastructure. Why shouldn't they be after all these years? But they also know the ability to mobile and social enable that infrastructure, the ability to web enable that infrastructure, the ability to do analytics of the data in that infrastructure is going to require a new model. We call that a hybrid dynamic cloud. This was why it was so important for us to announce Power8 Systems being part of the IBM software model. With the software running across that in a software-defined environment, managing the data, managing the networking connection, managing that hybrid nature, this is what we find our clients looking for as we move to this new era of computing. It's also, though, not just about the software cloud. It's about how do we bring this capability to our mid-sized managed service providers around the world. Those who have sort of taken and drawn a circle on the map around a state, around a country, and said, you know what, I'm going to focus on this area. And I'm going to focus on this client set. So with Power8 Systems, we've announced capabilities we call pay-as-you-grow, allowing consumers to buy technology at a very low entry point, often in an OpEx model versus a CapEx model, and then we grow with their business as they grow their business. So it's targeting the MSPs. And finally, as you heard Gordon, Brad, and the others talk, it is, though, still about how do we get power technologies into these new hyperscale data centers. And it's going to be more than just the systems I deliver. It's the technology, though, brought in new creative ways, and you see some examples of that from the Tyan motherboard sitting on the table here. Certainly, this is focused on just the development platform, as you heard. But again, lots of possible use cases for new models, new business models, new buyers, new markets with Power8 technology. So this is how we bring power technology and the economics and security around it to the marketplace for cloud. So let me start to wrap up before I invite up a client of ours. As you heard with the new Power8 systems, it is a commitment to openness like you've never seen from us before. Sure, IBM as a company has always been committed to openness, but I hope you'd all agree the boldness by which we are opening up the Power architecture, very similar to the ARM model for mobile, is unheard of in the server marketplace. Secondly, these platforms are designed for data, all kinds of data. They're optimized with the IBM software stack as well as software across the industry. And finally, the Power8 systems for IBM, as you've seen, they are absolutely ready for the cloud. With a very economic value proposition, we believe in the cloud space we can deliver up to 20 to 30% better price performance than an x86 platform. So, it's always great to hear from a client instead of a vendor. Hear from the voice of somebody who's dealing with these problems today. In a moment, I'd like to bring the stage a good friend of ours, Cameron Kahn, Vice Provost of Information Technology at Rice University. We've been working with Cameron and Rice University now for several years. Actually, they have a Power system, Power 7-based system, deployed on campus for the last 7 years, working on dealing with genomics. Some of the real hard challenges, I think you'd agree, from an application perspective around compute and around data. One of the interesting facts that Cameron has shared with me is if you do an individual's DNA mapping, each one of us here in this room, it would take about a terabyte per person. A terabyte per person to do a DNA mapping. I think you'd all agree that's quite a challenge to figure out how to do that and how to look for solving some of the diseases that they're focused on, whether it be cancer, AIDS, or other more complex diseases. So with that, Cameron, why don't I invite you up on stage and why don't we chat about what our two companies are doing together. Thank you for joining us today.
Thank you. Nice being here.
So I got my cheat sheet on the questions, I know. So Cameron, why don't you spend a few moments telling us about the environment you have at Rice University and some of the projects and so forth going on.
So we have a pretty robust environment. We have a Blue Gene x86 Power 7s. And a lot of that work we're doing is based upon the architecture. For example, on the Power 7s is the Watson architecture. And of course, there's a lot of, being in Houston with being the oil capital of the world, energy. And then across the street, we have also the Texas Medical Center, which we are a member of, and we work very closely, our faculty works very closely on quite a few different projects, which have to do with trying to solve, big problems and trying to get solutions to this. So as you can see, data plays a huge part of that. So in genomics and genomics sequencing, and that's becoming big. Analysis of protein structures is another area. And then protein packing with the defects as functional markers and drug tests, drug targets, that's another one. And then analysis of bacterial genomics. So a lot of this, of course, takes a lot of data and so forth, which I'll talk a little bit about. But these areas are all interdisciplinary, meaning it's bioengineering, it's sciences, it's computer science plays a huge role into that. Clinicians get involved with this. And then so the partnerships we have with the energy companies and the medical center and so forth work really well. This is something which one of the things our universities like ours, which is research-based, wants to be able to solve these problems, the ones you've talked about. And it's important for us to have the technologies which we can do that with.
Yeah. I should have mentioned before Cameron came up, we share something else. He's a fellow Texan. Transplant Texan, I might add. So, one of the great benefits our companies have is we have the same sort of proximity of talent and skills being within Texas. Certainly a lot of the Power team is located in Austin, Texas. Obviously Rice is really a global leader, but also in Texas. So it gives us that chance to collaborate together. To that point of collaboration, you talked about some of this focus within Rice and the medical industry around big data. As you look at Power8 technologies, you've had a chance to get a little peek at it here before today. And how do you see kind of Power8 helping Rice and some of your projects solve the big data problem?
Well, I think we really need to understand the landscape we're living in. I think you have to start with that. I think everybody knows that, for example, the cloud is playing a huge role. You have big data analytics is another big player. And then you have, of course, social playing, because in many ways people want to get their answers. I mean, look, at the end of the day, I do my banking, yep. I use my iPhone, I use that for so many things, mm-hmm. right? So
you don't want to wait.
So all of this needs to be ready, right, and instantly available. So one of the things is that, big data is for us is like, the velocity and the variety. It's unstructured. It's basically volumes of petabytes of data. We're dealing with all across, and it's hard to do that on a commodity servers. It's just we haven't been successful trying to do that. And so, for us, it's so important to have those multiple, cores, and then. Having more threaded cores is so critical, because we are trying to run these experiments and be able to get the answer back, because you don't want to be doing it in days. You want to be doing it in hours or even less than an hour, right? And so if you look at computing itself, right, performance is such a big factor, because since the invention of computers, we've been trying to get better and better at performance, right? And that's the key ingredient. And so faster IOs are so critical for us, and the latency is very critical to us, and performance. Now, one of the great things about the Power7, we really have done a lot of good things with it, but one of the great things I hear about is the massive memory. Mm-hmm. And now you guys have gone and doing something to the Power8, which is even majestic, from the memory point of view, which I think is going to be welcome for a lot of the researchers around the world. The whole Linux environment, I have certified Linux people. We've been on Linux, we've been open, universities for the most part do that. So the open power is a great thing. Why? Because collaboration, right, and sharing.
That's natural for you guys.
Right, and sharing.
It's normal in the academic environment.
Innovation is a big deal for us also. And then be able to develop things together, right, because it's cost more if you try to do it on your own. And so sharing is very important to us. I think when we look at some, the people talked about the data center. When we look at the footprint of the data center, we're also concerned, because we have data center, and we're trying to save on energy and so forth, and the footprint and space, and all of those things, I think, play into this really well for us. So that's another thing. Certainly, we are living the private and hybrid and public cloud. Mm-hmm. Let's face it, everything's not going to be in one place. It's going to be everywhere, right? And so pieces, and it's going to be virtual, right? So Linux and KVM plays a huge part in those heterogeneous environments you're trying to, bring together and integrate as well. It's Cognos is another thing we have. We have SPSS, which is across the board at our university. So I think this is very important, that the fast piece for us to get things done.
Yeah, all this performance you talked about is sort of in the context, though, of how do you speed up insights, right? I mean, so it's not just about the performance, it's about the benefit to the work you're doing, particularly around genomics in terms of speed, right? I mean, not only are we not patient these days, but also you're trying to get to insights and answers with the medical industry faster than what they could have in the past. I think that's fair to say. Right?
Yeah. And it's very important that the memory and the hardware be aligned to be able to do that. It's important that everything comes together, because we're talking about large-scale data sets, right? And so you have to be able to do things very quickly, fast, back and forth. And flash is another piece which we're looking forward to, because you're talking about in the tera and terabytes, right? And that's always good for our researchers. From our perspective, we want to be able to convert these discoveries into development, right? And then lead that into, some of them are very complex things our faculty work at. But to be able to cure these diseases and work on so many interdisciplinary areas, which I talked about earlier, it's important that, we have the capabilities to do that.
So jump forward. I know you have a business plan, a vision for the work you're doing. So jump forward 2 to 3 years, and where do you think you'll find yourself at in 2 to 3 years from now in terms of you'll have had Power8 Systems, you'll have had some technology from our Open Power members, as you said, that's very natural within the academic environment, that open collaboration. Where do you see all this in a couple years from now?
Well, we're probably be pushing you even more, right? I mean, because...
Good. I hope you do.
And so hardware, I think, again, hardware aligned, closely with the memory is going to be a big factor in trying to come up with some of these solutions to the problems. Linux is going to play a big role no matter what, how you look at it. And then, the whole cyber infrastructure we'll be building is going to pay dividends in terms of analytics. But at the end of the day, that's really what matters anyways, how you actually get that information to someone who can make decisions, right? I mean, you're making decisions about people, right? And that's important. So analytics will play. And really the next generation of this Power8, which we are going to be looking at, I think will go a long ways in terms of helping us, put all of these pieces together, the software, try to integrate this, the open power. I think those all play in pretty well.
Oh, great. One last question and one last quick one, because I know we're just about out of time, but this has been great. You deal in an environment with a lot of students as part of academia, let alone reaching across the university and then reaching outside the university. Mobile, social, how does that factor into this whole environment?
Example is each student, we did a freshman survey the last 4 years. They bring about 3.2 devices per student. Yeah. Right. So
my kids are going to help you double that, by the way.
So social mobile plays a big thing. I think it all comes down to the presentation layer. I think you got to be able to do that for everybody. And the social piece definitely integrates, with the mobile piece. And then all of the things you want, we talked about earlier, is like when you go banking, you want to be able to do it there and to be able to do it fast. And I think it's this brings a lot of change in culture, how we go about doing this. And so I'm looking forward to working with the Power Systems.
Well, great, Cameron. Any last thoughts before I thank you for your time?
No, I'm glad that we have the Open Foundation, Power Foundation, and because from a university perspective, open is what we want to be able to do even more.
Fantastic, Cameron. Thank you again for your time. So first off, again, thank you to Cameron, and not only to Cameron, but for his great story, but obviously for Rice, who was literally signing the Open Power Foundation paperwork, I think this morning while having a cup of coffee. So one of our newest members of the Open Power Foundation. A couple points just to summarize perhaps what I picked up from Cameron's talk. Certainly you heard loud and clear the role of openness, and why at this point in time now in the industry, certainly from his perspective, not just in academia, but working across the big data problems he sees in healthcare, the role that openness plays. Secondly, it does come back to big data. The amount of data generated in some of these efforts to solve the big data needs of complex diseases is just phenomenal. It's unbelievable, some of these grand challenges that Rice University and others are working on around big data, and therefore the role we see IBM's new Power8 Systems playing in that. Now, let me invite up Tom Rosamilia, Senior Vice President of IBM Systems Group and Supply Chain. Tom, one of the wonderful benefits of hardware, you and I have joked about this, you can touch it, you can feel it, you can show it off.
You can unveil it.
You can unveil. What a great idea, Tom. So why don't we, for the audience here, sort of showcase what a scale-out Power8 environment might look like. If you're ready?
1, 2, 3, let's go.
So, Tom, I think a pretty good-looking system, you'd say, right?
It is a good-looking system. I must say. What are we looking at here?
Yeah, so this is 20 2U servers, 2 sockets each, of Power8 systems.
Therefore, 822.
822.
Okay.
S for scale-out, right? 8 for Power8, 2 for 2 socket, 2 for 2U. Very simple
good
to understand, right?
Even I can figure that out.
Yeah.
That's good.
A couple of neat stats.
This looks just like an internet data center play.
Well, that's what we think. Industry standard rack, obviously a lot of scale-out servers of it, 480 cores, over 3,800 threads. You know, we were talking with Cameron a second ago about 1 terabyte per individual's DNA scan. Well, I'm happy to inform you there is 20 terabytes of memory in this system. But now with some of our new CAPI capability and flash attached, there's 100 terabytes of memory potential in this rack.
Awesome.
That would be 100 individuals' DNA in memory, again, working on that big data analytics problem. Just in this rack.
Awesome.
So, anyhow, pretty exciting times,
I'm
Tom.
excited. That's terrific.
Thanks
Thank you,
for
Doug.
coming up.
So I just wanted to add my thoughts. As Doug said, I'm the Senior Vice President of hardware for IBM, and I welcome all of you here in San Francisco and around the globe to this live stream. I just wanted to add my commentary on this. And it's interesting to me, I wanted to reflect on a few things I heard today. I heard, originally from Gordon and from Brad around this absolute need for the systems level optimization and why we have to go from chip optimization, which we've been doing for a long time, systems level, which we've been doing, but now we've really broadened that to include an entire ecosystem. And that's really where the key to this Open Power Foundation has come from. Gordon mentioned it specifically. And this third generation of being able to do this in a more standard way rather than people having to roll their own, I think is fantastic. Nvidia, we heard their full software stack is important. They're GAing in fourth quarter. I think there's a fabulous story about the kind of performance benefits we see in a combination of the wonders of Power8 and the wonders of our partner ecosystem around this and what kind of performance speed up we can get. MNOUX with RDMA, same kind of thing. And wonderful to see the tie-in board on stage with us today, this Open Power Foundation driven, development-led Power8 system on stage with us, and the one to my right, our deliverable of our Power8 system, which is a brand new system for us. We also talked about China. Brad's heading over there really soon, I think tomorrow. I'll be over there next week. You saw a lot of members from China. China plays a big role in this, and I'll be over there next week to host sort of the impact-like event around this power announcement in Beijing next week and meeting with lots of our partners over there, and that is an important part. And then we got to hear from Cameron, and I will correct one thing Cameron said. Gordon, he meant to say his Android-based device. He didn't mean to say his iPhone. Just to be clear, we'll have to set the record straight on that. But hearing about the time to value and what people need is real time. I want instant connection. I want instant answers. We see the people's tolerations for latency these days is 0. They want to know answers within 5 minutes if I post something online and within 5 seconds if I go on my phone, whatever it might be, and get those kinds of answers. By the way, Cameron has a rich history with Linux and with IBM. His resume goes back a long way. In fact, he was part of the team that helped us really get Linux going on the mainframe. So I think it's quite good and a good parallel for us. That was back in 2001, now in 2014. Now, I wanted to reflect on a year, because I've been in this role for about a year. I was running strategy for IBM before that, and I got to see a lot of what we're talking about today, which was where we see innovation going and where we're seeing it having to go. And it was about a year ago, Gordon and Brad and I got together, and we started talking about this. Brad had already been on this journey, but we got to talking about this. And I want to just congratulate the Open Power Foundation on this point. It's a level of graduation. Not quite at the university or doctorate level, but we celebrate elementary school graduations, we celebrate middle school graduation, we celebrate all kinds of. This is a level of graduation that I've seen to this level of being able to go public and to inviting more. I think about the original 5, I call them the fabulous 5, that had the vision, that had the commitment, that had the intellectual property that they were willing to bring to the table and the flexibility to say, let's get together on this and make a difference. It was interesting. I was talking to a reporter yesterday and then again today. And he mentioned, he says, the story's interesting because you've really got 2 things going on at the same time. And he's absolutely right. We do have 2 things, and it's culminating today. The combination of this Open Power Foundation and what we've committed to around openness and the launch of our brand new Power8 system, all coming together. One been on a journey for a little bit longer, the other one been on a journey for about a year. But we think about the original 5, and they had influence on this box. They got to change some of the specifications that we made in the last year at the system level for this box. So there were things we had to change to accommodate, whether it was energy levels or speeds or other things that we had to accommodate to build this. So they've already had some influence on what we're doing, and they'll have even more in the future, which I think is wonderful to get that kind of collaboration, not just from the 5, I was going to say 25, but now 26 members of the Open Power Foundation. Now, why now? We got that question earlier. I think the time is absolutely ripe, as Brad said. We see this level of collaboration absolutely necessary, and reaching out to the rest of the industry is a great way for us to get that collaboration and to deliver on that innovation. Why power? Built for big data. As Doug said, this journey's been going on for 3 years. We saw this movie coming, and we got to anticipate it. And building this system for big data is really one of the principles that we followed from the beginning. Actually, back when I was running the power business before Doug got there. So, this has been going on for quite some time, and we anticipated it. And I think power is a great foundation upon which to build. If we talk about it, and I know we talked about a lot of gorpy things, but the speed of the threads, the strength of the threads, the number of threads, for those of you who know what that means, it means great results for performance, especially around big data applications. So if I want to know things fast, I've got to be able to get that answer very fast. The foundation, if we look at this from a Watson perspective, we take Watson, which ran on Power 7, we take Watson and run it on Power 8, 5x faster than what we saw from Power 7. 5x faster for Watson, for our leading cognitive computer out there. So some terrific advances, and again, that's obviously a big data problem that's out there. Now, why open? And we got that question, and I think it is profound. And Doug mentioned this earlier. We've been on doing open systems in IBM for quite some time. If you think back on the days, and I got to manage the WebSphere business for a while, really embracing the Apache model has been something we've been doing for years. We contribute, we innovate on top. We did the same thing around Linux, not just on the Z, but on all of our systems. We embraced Linux. As Doug said, we made that commitment in the early to mid-2000s. We didn't start it, but I would say we added a lot of fuel to that fire around Linux in the justification and making it really meaningful and making it enterprise class. Cameron's help on that as well. Right? So Linux, Java, and Apache and what we've done there. Eclipse is another good example. We bought a company a few years ago called Rational. We contributed the Eclipse-based code for developers. We innovate on top. We're doing the exact same thing with OpenStack these days. Right? As you heard, there are so many folks in IBM that are donating and contributing intellectual property to OpenStack, and we're harvesting that benefit. We see it as a great development model that we're able to harvest from, and it's a great collaboration model. But what's really profound here is this has never been done before around enterprise-class servers, not to this level. Not to the level where we said willing to license. There were only a few people back in August 5th, August 6th, when we originally made the Open Power announcement, who really got it and said, wow, this is unique. This isn't just about a foundation. This is about IBM being willing to license one of their prized possessions. Majestic, I love that word. Well, remember that word, majestic possessions. And being able to take this and make it open, make it available to others on a license model. People can literally take the IP, the license model, and do derivative works. If they want to contribute it back, they can. If they want to make it their own, they can. They want to do that here. They want to do that in China. They want to do that in Europe. They want to do that wherever. They can do it. So they've got freedom to innovate, again, and contribute back or to keep it to themselves. Never before have we seen this level of openness, this commitment to openness at the enterprise class server level with the ability to do what this machine can do. So, to me, it is the combination of two amazing things happening at the same time. This graduation point for the Open Power Foundation, if you think about this last year, going from 5 to 26 members now. And again, these are not people coming just saying, oh, I'll put my name down, don't call me. These are people bringing what we call sharpened pencils to the table and saying, here's what we need to do to change. And we make changes and we'll continue to do that. As Doug said, a year of promises, KVM, Linux porting centers. I got to visit the one in Beijing in November and watched lots of companies porting their applications. We've got over 800 now ported to Linux on Power. Wow. Quick, really rapid turnaround for us in this case, right? We made the $1 billion investment. We started to add members in January. I announced at one of our events at Partner World the addition of Samsung. We've added lots of members since then, and you got to see a lot of new members. We need to make a lot of noise about this movement to 26, because in the last 3 weeks, we've added a lot of members. And we've got a lot more interested. We will be a little bit more selective now. We want to make sure people are bringing something to the table. Sharpened pencils, ideas, intellectual property, creativity, their brains, bringing to the table on how we can do this and make this innovation. So the combination of that Open Power Foundation and what we've been doing for a couple of years now on delivering the premier big data system with the economics for the cloud, right, with the compatibility and addition of Linux to our environment. Yes, we've had some before, but this is far more commitment to Linux than we've ever seen before in the Power brand. Yes, by the way, this system is great for our AIX customers. It's great for our System I customers, and it will be great for this scale-out world that we're embracing wholeheartedly, as you can see, around Power8. So I'd like to thank you all for that. I really do appreciate your attention here. And now I'd like to open things up for Q&A. So I'd like to invite a few people back up on stage and open things up for questions. So with that, we can bring the chairs up. Some of the folks that have been on stage before, Doug, come on up. I'd like to invite Gordon up, and Brad, and Chuck, and Sumit, and Jalad, and Doug to come up and join me. So, you know, before I do that, just thank you for your time. I know that that is a precious commodity for you. I appreciate you spending a couple hours with us to hear from us our point of view on what we think is absolutely fantastic news today. Come on up, Cameron.
Come on, Cameron.
Thank you. And I will moderate. So questions from the audience. We have microphones?
See.
Yes, right down front. I'll repeat, so we'll be able to do that for our folks on the live stream. Oh.
Jack Clark with the Register. Why couldn't this be achieved with ARM? Why did you do Power? You know, you could have done this years ago.
I'll let, who wants to take that question?
I'll take that. I'll go with that. Yeah. So ARM has definitely a licensing model that enables some of the innovation. You can get ARM parts and innovate with that. But we're talking about the data center. We're talking about servers. We're talking about full 64-bit capability. And the technology we have is ready to go to do that right now. You can take that motherboard right there, load it up with a hypervisor, with a Java, with Linux, and put your 64-bit apps on it and run it right now. ARM's not quite ready to do that yet. So you can't do that right this minute with ARM, and it'll be a while. So that's probably the biggest difference here. We're ready to go right now with our technology.
Anybody want to add to that? Or I think that's well said. I think it's the ARM model, but think of that, about this for the server class, right? A lot of us have ARM running in our mobile devices right now. Next question. Yes, from the front. Wired. Yep.
This question for Mr. McKean. I was wondering, so it's sort of the same kind of question, but with respect to Intel. I mean, Intel, you can run all these 64-bit apps on already, but there seems to be something about the openness of the platform that gives you something you can do that you can't do on the Intel platform. Could you talk a little bit about what you expect that to be?
Well, Google is actually very committed to the open community, and recognizes the value of an open community for really having a multiplying effect or an amplifying effect on the innovation that can take place. And when this group got together, it was a group that we recognized as having a common goal, wanting to realize that same sort of impact by working together. You know, we will be innovating in all places that we can, but this represented a unique opportunity for us with working with Power here.
I think if I could add to that, Tom,
Please,
from an IBM power perspective, right, it's a couple simple differences I think about it, and I've had a chance to run our engineering, x86 engineering team in past roles, clearly, if you look at what we're doing here today, it is around opening the platform up in new levels we've never seen in the server market before. So you can, as Tom described, do a derivative processor based on power. One of the Open Power Foundation members, Suzhou PowerCore, a new company formed in China in December last year, actually has every intention of doing that, taking the Power8 technology, doing derivative writes for the market and the clients they want to serve. You can only get an Intel chip from one company, last I checked. So that level of openness is not there. I mentioned CAPI, right, my superhighway. Again, that's a new pipeline of innovation, bringing accelerators, I/O, memory, closer to the processor, right on the same address space that the technology Brad and I and our teams developed. So once again, it's about the ability to, in a community spirit, create innovation, because we acknowledge, certainly as IBM, no one company can do it all these days. The market is moving too fast around mobile, social, analytics, cloud, all those technologies moving so fast, no one company should have the right to own the innovation agenda, and that's what we agree with.
And this way we get a lot broader participation, as you can see from the 26 members that have joined so far. So I think that's well said. And by the way, while we don't like the term CAPI, we are all CAPI happy, right? So
very happy about CAPI.
Happy about CAPI. Next question. In the back, on the aisle, microphone heading your way.
Thanks. Hi, Jessica Lipsky, EE Times. Can you speak more to China's role in this ongoing development of open servers?
I'll start there. I mean, we've had a very successful business in China around our power technology for quite some time, in addition to other technologies from IBM. So it's obviously a big market for all of us, for all the world. Having been there many times, we see lots of great examples of where we've done very well in the Unix marketplace in China. For us, this is about the expansion of Linux in China. And one of the things that we found is that more and more of the companies in China want to be able to do things indigenously. So they want to be able to do things where they can do exactly what Doug said, is create their own models, sell their own capabilities, add their own values, so do their own derivatives around this thing. And so the combination, as you saw from the list, of not just Suzhou PowerCore, but Team Sun and Inspur and some of the others, the Research Institute of Jingzhou, I mean, they're all interested in this because of the reasons. Actually, the very question we got up here is they have the flexibility now with open power to get that kind of capability they don't have anywhere else. Big play in China. That's why I'm going personally there. Doug got to go to Las Vegas. I get to go to China. Not sure who works for whom, but we'll see. Anything else? Please. 1 second for the microphone. I'll change sides. Don't want to stand too much in front of Tyann.
Paul McGowan with Zato Health. And in the genomic space, but also in work that we've done in the intelligence and defense communities, we've been waiting for a long time for a platform that would enable computation across data centers. So 100 genome scans could reside here, but there will be gene scans in different institutions because of privacy control and so forth in different countries. So this seems to be a tremendous opportunity that IBM and the others have brought to the table here to be able to do cross-domain, cross-data center computation where the data don't have to be all moved to a centralized location. Does anybody want to make a comment about the path to get there?
Well, I think it's really important, that we know that the hybrid cloud is really a solution to that. And of course, there's BBAs on the HIPAA data and all of that you got to go through. But at the end, I think we really need to all get to the sharing piece. And I think we're getting very close to that because you have a lot of people who do research, but they're doing research with so many different groups, and it's being done virtually. And I think security plays a role in this because you want to be able to actually, follow them all the way through and know who they are. And it's more like not at the organizational level, but more on the individual level. So I think that's going to play up. So to me, the public and the private and the hybrid are going to play a big role in this. You're absolutely right. Everything is not going to be in one physical place. That's just not going to work. And I really truly believe it's more of a collaboration and sharing, because that's how we're going to get to the, when you talk about open, you're really talking about innovation, right? So you'll get better innovation and better sharing, better development done as we had seen from Linux. I mean, Linux was a great example, but I think the cloud is getting better. It's getting there. I think we need to put more trust and be able to make sure that the security pieces are there, and I think a lot of vendors are working at that.
Brad, did you want to add to that at all?
Yeah, I was just going to add. I was going to just chime in. So, I'll put my power development lead hat on. One of the top work groups that I have with my development team is what we call hybrid. Much of the use cases and description of what Cameron described is what we're solving with the technology. And, both Doug and Tom alluded to it. The first step to enabling hybrid is we put power into the cloud. We're putting power into our software cloud that will enable that. And we're going to enable our power systems that work around the world to work better with those systems in the cloud and other clouds as well, to enable that hybrid computing. So that's a use case that's very, very important, and we think is going to have a big impact on the industry.
I would just like to add that we get networking help, and we also get GPU help in solving this problem from some of our founding members, so some of the fabulous 5. Yep. Any more questions for us? Okay, hopefully we've answered all your questions. I think that, just to sum this up, this is a profound moment. This is a big moment for us around the launch of Power8, as we've described, and we'll keep describing to you over the next couple of weeks in all parts of the world. But it's also a profound moment for us around our commitment to open systems and the graduation of the Open Power Foundation. We are open for business. We're ready to take on new contributors, people who are willing to bring their ideas, subject to the votes of these guys and the other platinum members in the group, but people willing to bring their ideas, bring their intellectual property, bring their creativity, and bring their energy around this innovation, which we see as really the road to the future. So thank you very much for your participation today. Some of us will be around for one-on-ones and for Q&A, and for those of you online, I hope to see you in some part of the globe at some point in the next couple of weeks. Thank you.